Hence, mechanics, which is mainly a study related to force, can be divided into three main categories. One is classical mechanics, which is initiated by Newton. The second one is relativistic mechanics, which is proposed by Einstein. And the third one is quantum mechanics. Now, this relativistic mechanics and quantum mechanics are not in your syllabus, so we will take up the study of classical mechanics. And this classical mechanics can be further be subdivided into two categories. One is solid mechanics, and the second one is fluid mechanics. Now, those substances which actually flow on the application of force is known as fluid, like liquid and gases. Now, this solid mechanics can be the study of solid mechanics can be divided into two categories. The first one is rigid body mechanics. In this branch of mechanics, we will consider the body to be a rigid one, and on the application of load, the application of force, the body will move. Therefore, there will be a displacement. So all the force acting on the body, external force acting on the body, will dissipate it for producing its motion. And the second one is mechanics of materials. In this branch, we will consider the applied force will produce a deformation in the body. That means the displacement will be in the molecular level. So due to the deformation, there will be certain properties. We will have to address certain properties like stress, strain in the materials. So these are the two branches of solid mechanics. Now, as we are dealing about motion or rest, state of motion or of rest, so this rigid body mechanics can further be subdivided. This rigid body mechanics can further be subdivided into two categories. The first one is static. In this branch of mechanics, we will deal about rest or of equilibrium of an body. So when there is no force is applied over the body, so body is in rest condition, or there are lots of forces acting over the body, but the net force or acting over the body is zero. The second one is about the branch of mechanics which actually deals about motion of body, that is dynamics. Now this dynamics can be divided. So we will take up the study of motion of bodies in the branch of dynamics. Now study of motion can be done under the heading of dynamics into two different ways. The first one is kinematics and the second one is kinetics. Now the difference between kinematics and kinetics is this. In kinematics, we will not address the cause. So we know that for every kind of movement, there is a force responsible. So we will not address the force here. So force not addressed. But the effect of this force, that means displacement, velocity, acceleration, we need to calculate this. So these needed to be calculated. And in kinetics, we need to address both cause, that means force, and its effect, we need to determine the force along with the effect like displacement, velocity, acceleration, etc. Now the difference will be clear if we take up an example. Suppose we have two stations, station A and station B, which is situated say 120 km apart. Now a train which is moving with a velocity of 60 km per hour leaves station A say at 10 a.m. morning. So when will the train reach the station B? Now we know that in this kind of situation, as the velocity is not changing, it is constant, so we can determine velocity by a formula v is equal to d by t. So it implies that time t is equal to d by velocity. Now here d is distance is 120 kilometer and velocity is 60 kilometer per hour. So our time required will be 2 hours. So obviously train will reach the station B at 12 p.m. So for solving this kind of problem, we do not need to address the force. That means we do not need to find what amount of force the locomotive is actually applying. So this kind of problem is solved under the headings of kinematics. But all of we know Newton's second law, that is force is equal to mass into acceleration. Here we can find that force is the cause which is actually producing an effect, that is acceleration. So we are addressing both cause and effect in this kind of situation. So by this equation actually, so this is known as Newton's law of dynamics, as we are addressing both cause and effect actually. Now this mechanics of materials can also be subdivided into three categories. The first one is strength of materials. The second one is mechanics of elastic and solid bodies. The third one is mechanics of deformable bodies. We need to study some of the part of strength of materials where we will discuss about stress, strain, etc. So these are the different branches of mechanics of materials. Similarly, as we have done in case of solid mechanics, this fluid mechanics can also be the fluid can also be in state of rest or of motion. So depending upon those two conditions, we can also divide fluid mechanics into fluid statics and fluid dynamics. So these are the different branches of mechanics, and some of the part of it we need to study.